All right, well, I guess we'll go ahead and get started to keep on schedule for make sure we don't take too much of everybody's time. Good afternoon, everyone, and I just want to say thank you for taking time out of your busy schedules to be a part of our Combined Heat and Power webinar today. My name is Caleb Powell, and I am an environmental scientist for the Office of Policy and Sustainable Practices here at the Tennessee Department of Environment and Conservation. I will be hosting the webinar today for our wonderful speakers. Everyone is muted upon entry to reduce the amount of background noise, but if you have any questions or comments, feel free to ask them in the chat box, and one of the presenters or myself will work on getting those answered. I'm currently sending out a test just so everyone can see what that chat box is. If you have any questions, feel free to send that, and I will ask those questions to our presenters. I really appreciate everyone's interest in this webinar and the topics it covers. I hope you find that the information is prevalent in some form or fashion. And to give an overview of what we're going to be covering today, we have Art Sandberg to talk about implementing energy resiliency through combined heat and power, and Darren Kaser to talk about Yoplai's yogurt waste to energy. With all that being said, I would like to introduce our first presenter, Mr. Art Sandberg. Art is the Assistant Director for the Department of Energy's Southeast Combined Heat and Power Technical Assistance Program, and a Program Director at the North Carolina Clean Energy Technology Center at NC State. Mr. Sandberg specializes in combined heat and power, renewable energy, and industrial energy efficiency projects. Mr. Sandberg provides educational outreach and conducts technical assessments for facilities that are considering deployment of clean power and or energy efficiency upgrades, including CHP. Mr. Sandberg received his master's degree in meteorology from Rutgers University and has spent most of his career providing air quality and environmental permitting and consulting services to the power generating and renewable energy industries. With that being said, it is all yours, Mr. Sandberg.
Okay, well, thank you very much, Caleb, and thank you everybody for attending, and also appreciate your time this afternoon. So my presentation today is going to be an overview. I'm just trying to figure out, okay, there we go. So the presentation today that I'm going to be giving is, first it's going to start with a kind of an introduction to the program that Caleb mentioned. It's a very long name, Combined Heat and Power Technical Assistance Partnerships, or CHP TAPs for short. Just a little bit of an overview of what that program is, what it does, and what its purpose is. Then we're going to talk about CHP specifically. First about the importance of CHP in providing for resilient energy, and we're going to talk a little bit about that. Then some of the CHP technologies, and a bit about the market, the current and potential market for CHP in the United States, in the Southeast, and Tennessee in particular. And then kind of conclude that section on some additional benefits of combined heat and power and how it works and some of the benefits. A couple of project snapshots for a couple of CHP facilities in Tennessee, and then conclude the presentation with some of the resources offered through the U.S. Department of Energy's Combined Heat and Power Technical Assistance Partnership. Okay, so the DOE CHP TAPs has really three primary components to it. We work with end users, so that's people like Darren at Yoplait, other manufacturing facilities, or any institutional or commercial facility for that matter that has a large thermal and electric load that is looking at ways to reduce energy costs, increase reliability and resiliency, or there's other reasons why facilities would want to have CHP. So we talk with facilities to understand what their objectives are so that we can help kind of chart a course for what the best paths are moving forward. But we also work with stakeholders. Stakeholders could be like Caleb at TDEC, for example, and other states within our region. So from the map on the right there, we cover the Southeast, 8 states, basically from North Carolina down to Florida and out the Mississippi River and up to Kentucky. And so we work with these individual state policymakers, regulators, utilities, et cetera, to discuss potential barriers to advancing CHP so that facilities that can benefit from it can find it as economic as possible. And then we also have a bunch of technical services that I'm going to get to at the end of this presentation that helps facilities identify if their plant or building or school or hospital is a good candidate for CHP, and we do that at no cost so that we remove the risk of kind of that upfront assessment as to whether or not CHP makes sense for a facility. So again, here's the map of the whole country. So we're basically broken out like the EPA regions. If you're familiar with the 10 EPA regions that there are around the country, we're CHP TAP Region 4 in Southeast in the lower right there. And we also cover the Virgin Islands and Puerto Rico. The map shows Virgin Islands and Puerto Rico and the Gulf of Mexico, but we all know that's not where it is. And our director, by the way, is Isaac Panzarella. He is all of our, Kimberly and my director for the Southeast CHP TAP. So start a little bit about resiliency, because really that is one of the big drivers, if you will, for interest in CHP, among others, but resiliency is key, especially in certain parts of the country. But basically, as you can see here, you know, resiliency really is the ability to prepare and adapt for changing conditions. But basically, the key words there are prepare, adapt, withstand, and recover. And what we're going to talk a little bit about is how CHP can help facilities enhance the resiliency of their energy supply. So this is a map of a hurricane, Hurricane Florence, which affected the Carolinas back in September. It seems like just a few weeks ago, but and I have a really cool picture here. So this is a satellite image of the surface of the Earth. Basically in north there is Virginia, middle is North Carolina, and then on the bottom there is South Carolina and Northeast Georgia, and a little part of Tennessee I think is on the far left. And this is about 3 hours before Hurricane Florence came ashore south of Wilmington, North Carolina. The key thing is this. So if you look at, if you go down about 3/4 of the way, you can see a big blob. That's Charleston. And if you're familiar with the South Carolina coast, you go by 26. In the middle there is Columbia, and then you make a right up 77. There's Charlotte. There's all the lights around Charlotte going up toward Greensboro, and then you head to the right on I-40. There's all your lights around Raleigh-Durham, where we are located. But if you notice, it's very dark down around Wilmington. Wilmington's a pretty big city. That shows the impact of to the power supply in the Wilmington area. Basically, that whole area was knocked out of power for several days. And that storm, as you know, just kind of sat there for a while. Besides the flooding that it brought widespread damage to the power grid in that part of the state. Another example is last year's Hurricane Irma in Florida. This is a picture of the hurricane as it was just south of Key West, and came around and devastated the southwest coast of Florida. And this slide here shows the path of the storm and the extent of the power outages in Florida. Now keep in mind that those numbers in that table on the right, those are not people, that's customers. So if you figure there's 2.5 to 3 people per customer, basically at one point or another during the storm, about 75% of the residents of Florida had lost power. Again, that was a massive storm. The utilities did all they could and brought power back as quickly as they could. But just looking at Florida Power and Light's service territory, 4.4 million customers alone were without power. Now, to residences and homes like your home and my home, it's an inconvenience. But if you're a hospital, if you're a chemical facility, if you're a university, if you're other facilities that have a critical infrastructure component to them, whether it's a facility where people went as a center of refuge, extended periods of not having power can be deadly, as actually we found out in Florida when people died in nursing homes because they could not get cooling for to bring the temperatures down in those nursing homes. This slide here is just 4 of several facilities that have CHP Systems and that were able to remain operational during Hurricane Irma. Okay, and that's one of the greatest things about CHP is because it's a locally generated source of energy. Many times on a grid that supplies just your facility, everybody else around you could be out. Your facility can remain operational. And there's a lot of costs to facilities that have to shut down because of not having power. Not only cost for production, but cost for raw materials. They get ruined, and so there's a large cost to industry when power is not reliable. Okay. This is an interesting slide that the DOE has recently put together because there's a lot of resources available today for facilities that want to generate their own power, right? There's solar with battery storage. There's different types of CHP, right? Biomass, biogas, natural gas, backup generators, distributed wind, and solar. And this slide is kind of interesting. So if you look at the circles there, if it's a completely open circle, then the facility is not likely to experience any impacts from that severe event, okay? But if there's like a half of a circle, it's 2 or 3 of those vulnerabilities, and the vulnerabilities are listed on your left there. It could be a fuel. In other words, what could make that type of energy source not work during certain types of severe events? It could be a fuel supply interruption, damage to equipment, performance limitations during certain types of weather or other extreme events, and then a planned or forced shutdown from that event. If the circle is full, then basically what that's saying is that any one of those 4 criteria can occur during that type of situation. For example, a standby generator in a wildfire could have all 4 of those ranking criteria met, and therefore would not make it an effective source for that type of event. So if you look at CHP with natural gas, okay, as an example, high winds, flooding, snow and ice, extreme temperatures usually does not create a problem for natural gas-powered CHP. And biogas CHP also, snow and ice, extreme temperatures, no real impacts. Sometimes there's an impact if there's flooding or high winds, but basically CHP in general proves to be a great source of distributed energy when there are extreme events occurring. So a little bit about how CHP works. So first of all, CHP is a form of distributed generation, meaning that it is a source of energy that is located at or near the source of the demand for that energy. It could be on your site or it could be adjacent to the site. It's integrated, meaning that it's integrated with an existing grid. It provides at least a portion of the electric and useful thermal energy, which could be for heating, cooling, process, steam, etc. So if you look at this diagram here, if you consider a traditional system, which is a centralized power plant from a utility and an on-site boiler, that system in general is about 50% efficient, okay? But if you look at a CHP system where you have your fuel providing both thermal and electric energy, that system in general is about 75%. So you have a more efficient system, which translates into lower costs also. And that's what this slide shows here. So an existing power plant is about 32% efficient when you include the transmission and distribution of the electricity from the plant through the power distribution system to your facility, and then an on-site boiler. So if you're trying to create, say, in the middle there, 75 units of energy between the power plant and your on-site boiler, you require about 150 units of energy. This is just generic units of energy. With a CHP system, you can provide the same quantity of energy, both thermal and electric, using about 100 units of energy. So there is a savings there. You're generating both the electric and steam or heat on your site. And this is basically a simple schematic on how CHP systems operate. You know, CHP systems can operate with any fuel, and our next presentation will be a great example of you know, how it doesn't have to be a natural gas or coal or fuel oil or whatever. I mean, there's lots of very innovative projects out there that utilize CHP, you know, to match their particular operations. CHP can be, you know, CHP system can have a prime mover that's one of several different technologies, as that middle block shows. And then it uses, basically, when you combust fuel, you create a lot of waste heat. That waste heat can be used, if you capture that waste heat, to generate electricity. So you're not only generating the thermal energy for a facility, but you can also take waste heat to generate from that waste heat electricity. So it's using the same fuel to generate both electric and thermal energy, which is what makes CHP unique. Again, these are some of the size ranges that are commonly used for CHP systems. You know, the very small end, you could have fuel cells or microturbines. Larger systems are usually either gas turbines or you know, boiler steam turbine combinations. Reciprocating engines really these days can run the gamut from very small systems out to 10 or more megawatts. So there's lots of options to evaluate which makes the most sense for your facility. So a little bit about some of the additional benefits. We've talked a little bit about the benefits of combined heat and power. We've discussed how it's a more efficient way of generating energy than the separate generation of electricity and heating or cooling. Its high efficiency translates to lower operating costs, but it also requires a capital investment. And sometimes that becomes a barrier to CHP project development. And we can have a whole separate webinar on financing options and incentives and other ways of helping with that capital investment. In fact, I think there's there'll be available a link, I guess, after this webinar to some of the incentives that are available right now. But that's just incentives, but sometimes there's local grants, and you know, it depends upon your municipality even sometimes, or your county. Of higher efficiency reduces emissions of pollutants. We already talked about how it increases energy reliability, and in some parts of the country where there's grid congestion, it can help utilities manage that grid congestion by you know, not having to rely on or providing all the power needs of a facility. If they're a large electric consumer, if they can generate some of their own electricity. Oh, okay. So earlier I had mentioned when we were talking about the Hurricane Irma in Florida, I talked about things like schools and hospitals and centers of refuge and chemical facilities and other facilities that are critical infrastructure. And there's a lot of focus on how CHP can help critical infrastructure meet their overall mission, okay, of whether it's protecting people or, you know, providing that refuge, or, you know, protecting lab experiments at universities or military bases, food distribution facilities where refrigeration is needed. CHP is an opportunity for those types of facilities to maintain a source of electricity during power outages, okay? And there's lots of stories out there about facilities that have, you know, operated for 4, 5, 6 days on their own when the rest of the grid was out. So You know, if it makes sense for your facility, it can be a great investment. So let's talk a little bit about the current CHP market. Okay, first looking at the United States in general. There's about 4,400 sites around the country that currently operate CHP systems, representing about 81 gigawatts of capacity, energy capacity. That represents like 8% of the electric generating capacity in the United States, 14% of the electric demand at manufacturing facilities. It avoids a lot of fuel consumption because of the extra efficiency and reduces greenhouse gas emissions considerably. And if you look at this pie chart here, you'll see that the largest market sector right now for CHP is the chemical industry, with almost a third of all CHP in the country. And in fact, the largest CHP system in the state of Tennessee is a chemical facility, Eastman Chemical. So this is currently the, not sure what happened there on that right there, but this is CHP in Tennessee today. There's 521 megawatts of installed capacity in Tennessee at 19 sites, which represents about just under 5% of the total installed capacity in the Southeast U.S., defined by those 8 states I showed you earlier. But there's a lot of potential in Tennessee. The U.S. DOE had a study done for them that looked at technical potential around the entire country, and there's about 6,100 sites in Tennessee that has the potential for CHP that would add about another 4 gigawatts of energy. On my copy, and my printed out version of this presentation, that big reddish sector on the right is chemicals, and that's 39%. I'm not sure why it didn't, I guess when I sent it, when I emailed it, something happened to that slide. But just real quickly here, to the left of that, you'll see air transportation at 3%. That's all from the FedEx hub over in Memphis. And then there's the hotels. If you go to, of course, pulp and paper is big in Tennessee, 37%, almost as big as chemicals. That 1% of the hotels there that you see, that's Opryland Hotel in Nashville. That's the one CHP system at a hotel in Tennessee that's large enough to register 1% of the total. And then there's hospitals and healthcare. There's currently 2 VA hospitals in Tennessee that have a total of about 7 megawatts of CHP. But that number is going to double on the next update because there was recently a CHP system commissioned at Erlanger Hospital down in Chattanooga. That is an 8 megawatt system. So, that number will double when this is updated next. Then there's food processing that I'm sure your play falls under. Colleges and universities, about 6%. And this is basically in the Southeast. I'm not going to spend a whole lot of time on that, but this allows you to compare Tennessee to the rest of the Southeast, and it's pretty consistent with the technical potential by state, and then by application is for the whole Southeast region. So I mentioned a couple of projects that I wanted to highlight. I'm not, just for time, I'm not going to spend a whole lot of time on them, but the biggest one in Tennessee is Eastman Chemical in Kingsport. It's an older facility. It's been upgraded several times and pushing just under 200 megawatts of capacity, but I mean it's huge. 17 boilers, 19 steam turbines. So it's a large system that's been around for a long time, and you know, as they say, you know, as the highlights there mentioned, that CHP is not the lowest upfront capital cost approach, but when evaluated on a life cycle basis, it makes a lot of sense for them. And this is a VA hospital up in Mountain Home, Tennessee. Again, one of the 2 VA hospitals that I mentioned earlier. This has been in existence since 2001, and you know, it reduced their energy consumption 20 to 30%, and saves about 5 to 15 million a year, over the contract term, I should say, saves them about $5 to $15 million. Right here is a slide that just shows, and I realized without seeing it, without having access to the links, but there, if you just go to that website on the bottom there, energy.gov/CHP Technologies, there's a series of fact sheets that the DOE makes available to the public that explains all the different types of CHP system technologies that are out there, the benefits, you know, and the advantages and disadvantages based on the type of application that you have. And then there's a great report that is done called the Combined Heat and Power, a Clean Energy Solution. That's just two of several resources that the DOE has available. If you just Google DOE CHP, you'll see a lot of information. And as we come toward the end here, I just want to go over real quickly the services that we provide. Because if you're a facility that, you know, from this discussion or other discussions have said, you know, maybe this does make sense for my facility, you can contact us, and we provide a no-cost screening model, a screening assessment of whether or not CHP makes sense for your facility. You know, whether there's the technical criteria are met, you know, both in terms of thermal and electric demand, and whether the economic payback makes sense. So we conduct an analysis, provide you with a report, and there's no cost, no obligation. We are fuel agnostic. We don't push any particular fuel, and whatever makes sense for your facility. And we can help you make the right decision without incurring any upfront costs. But once the screening is done, and if you do decide to proceed, then we become available to you in an oversight role, where, say, if you hire an engineering firm to do a feasibility analysis, we can oversee that process, or we could be available to provide unbiased third-party reviews. We can help with the investment grade analyses, procurement proposals, O&M and commissioning proposals and plans. Again, we are available throughout the process from, you know, I'm just thinking about it, all the way to I'm ready to throw the switch and get this system going. So we're available throughout that whole process, and we do that at no cost to the facility. So again, if you're interested in talking to us further, or in having a qualification screening performed to determine whether there is a good opportunity for your site, just give us, you know, contact us. My contact information is at the end. If you're looking to expand your facility and you need maybe additional power, or you're replacing a boiler, and maybe that's a good time to look at CHP, give us a call. If you're interested in state policies or other incentives or things like that, or if you would like to talk to us, you know, about, you know, participating in a corporate meeting about energy, we're available to do that. And so in summary, you know, it helps, CHP just helps you get the most out of your fuel dollar. It helps with reliability and the fact that we're available as a resource to help you make the right decision on whether or not CHP makes sense for your facility. So with that, I just want to thank everybody again for being on the webinar today, at least my part of the webinar. Really looking forward to the next speaker, Darren, about his system at your play. But if there's any questions either now or afterwards, we look forward to you know, responding, and or just give me a call or send an email, and be glad to talk some more. And again, we thank you for participating today.
All right, thank you, Art, so much. That was very, very informative. I actually learned a lot more than I thought I was going to. So I really appreciate your expertise.
Thank you.
And I will be. He mentioned a link to, with a lot of technical support. I'll be sending that out in the follow-up emails, along with Art's contact information. I'm not seeing any chat questions right now, but so if everyone will just hold those to the end, we will ask both of our panelists and get those answered for you. But so next we have Darren Kaser from Yoplait and General Mills. He's going to be talking about some combined heat and power examples that they've put into their facility. So I will pass it to you, Darren, and you have the floor.
Okay, thank you. You can hear me okay, Caleb?
Yes, sir.
Okay. All right. Well, thank you very much for the opportunity here. And what I'm going to present, it was referred to, is here in Murraysboro, Tennessee, is General Mills' largest food processing plant. And on this campus, we have a Yoplait plant and we have a Pillsbury dough plant. And this project was started in 2013, and it really deals with the yogurt plant. And I'm going to give you a little bit of history on it and bring you up to date as to how it has progressed all the way through till today. Oops. Okay, I'm going to advance. First of all, myself, a little biography about Darren. I've been in manufacturing 30 years, graduated from Iowa State, and I've been in food processing plants ever since. I started right out of college with Frito-Lay. Then I was with Purina, pet food division. It's now Nestle Purina. And then I've been with General Mills a little more than 20 years. And during the majority of the time I was with General Mills, I was the plant technical manager, engineering manager, in 4 different sites. Our Buffalo cereal plant, Cincinnati cereal plant, Covington, Georgia cereal plant, and then here in Murraysboro for the last 5 years. And then just recently here in April, I left the plant world and took a corporate job for General Mills, although I'm still based here in Murraysboro, as our global energy strategy leader. And so now I'm working full-time on utilities and sustainability for General Mills. Okay, so let me dive into the Murraysboro plant. Here's an aerial shot of the plant, and again, it's a big campus. Building 1 there is really our original Pillsbury plant from the 1970s. Building 2 is the Yoplait plant. Building 3 is a third-party frozen warehouse that's also on our site. And then 4, which is circled, is a wastewater treatment plant that is a key part of this CHP project because of the biogas that we generate there. And backing up as to why all of a sudden this biogas became available to us, you have to go to consumer taste preference trends that were evolving here. This is all about Greek yogurt and how Americans became, our taste for yogurt changed, and we became more interested in buying Greek yogurt versus our traditional. In 2010, less than $400 million was being spent on Greek yogurt, and you can see this chart just shows how rapidly our taste changed, and by 2013, the country was spending more than $2 billion on Greek yogurt. So, of course, General Mills decided around 2012, we better get in that business, and we make all of our Greek yogurt now at our Murraysboro plant. And the problem, which all Greek yogurt producers have, is that Greek yogurt, to get 1 gallon of finished Greek yogurt, you have to start with 3 gallons of milk. You'll get 1 gallon of Greek yogurt and you get 2 gallons of acid whey because the yogurt is concentrated and that process creates a lot of waste. Traditional yogurt is really a 1-for-1. A gallon of milk coming in results in a gallon of traditional yogurt. So this was a new problem for us at our plant. And what we did originally in 2012 is we pumped the whey into holding tanks, and then we hauled it off by truckload, and we were hauling off 15 to 20 truckloads a day, and it adds up quick. We were land applying that, and the total disposal cost was about $2.5 million a year. So we needed to figure out what we could do with this way. We already had an on-site wastewater treatment plant at the site. However, it was not large enough to handle this much inflow of new whey. So here again is our timeline and what we did. In 2014, we expanded our plant, wastewater treatment plant, by adding a large anaerobic digester to digest the carbon, the BOD value out of that whey. And then the water is, of course, filtered and so on, and it can be sent then to the city with basically no BOD because of this expansion. And then we also do, a side story is that we can send water to the neighboring golf course to help them with their irrigation. But the digester, of course, the bacteria in the digester create a biogas, and it was being flared off initially. And that's where the CHP comes in, because we had this source of biogas, and we didn't want to just flare it. So in 2015, we basically continued our work there to expand and optimize our wastewater treatment plant by adding a CHP unit to generate electricity and heat for us. And I'll go into some more details of that. Again, it was in total, sharing some numbers with you, we spent $7.5 million with that original digester project. It's a huge concrete digester, 6.6 million gallons. That eliminated our transportation disposal problem, our $2.5 million problem of whey disposal. It took our BOD to zero, and we had now more than 400 cubic feet per minute of 63% methane gas being produced, and it would spike up to 600, 700, 800 cubic feet per minute, depending on our production schedule. This is just showing the digester being built. Again, it's massive, 150-foot diameter tank, 50 feet tall. Besides just the tank, the digester, there was quite a bit of additional equipment, of course, that went along with that. This shows the inside of the tank. And again, in 2015, we were up and running and we were flaring. This is just showing that flare. So now what to do with that methane? We continued to, we looked at options, and Art just did a nice job explaining all the benefits of CHP. We had some other choices that we were looking at, but clearly the CHP was the right answer for us. And we used a different engineering firm to help us with that CHP project that had experience in that field. And the company is CHA Consulting Engineers. And you can go to www.chacompanies.com to see them. But we're very happy with the work that they did for us. They helped us, of course, spec out the entire system, and it included this skid where we are compressing the gas that's coming off the digester. We're drying it through a chiller dehumidifier. We're pumping it then at low pressure, like 5 psi, underground. This shows, this overhead view here shows where the compression skid is next to the digester tank, and then how we had to pipe underground over to where we located the generator. It's a couple thousand feet. And the reason we put the generator over by the Yoplait plant is because of the that's where we wanted to harvest the waste heat, and it just made logistically better sense to put it there. We actually were confident from our marketing folks that our Yoplait or Greek yogurt sales were going to continue to increase, and so we mapped all this out, and we had a plan such that we could add a second generator, which we have not done because sales have actually, they flattened out and then they started to reverse. But the generator itself is a 2,000 horsepower CAT internal combustion generator. And again, we are recovering the heat off of that into a large hot water tank that we use for all of the CIP processes that I'm sure everyone knows in the dairy how much time is spent cleaning, and we use hot water, and so that has helped us to not have to burn natural gas in the plant boilers, which was what we were doing previously to generate that heat. Okay, so just the CHP project itself, which again was started in 2014, was a $5.8 million project, and it originally was saving us over $800,000 a year in net utility costs. As the yogurt production has dropped here, it's tailed off a bit, and I'll get into that. But again, it can generate 1.6 megawatts of power at full load. That's about 20% of the Yoplait plant's electrical needs. And the natural gas offset, because of harvesting the heat, the waste heat, reduces our purchase of gas by about 50%. Here's something I was talking with Kimberly about originally before the webinar started. We took advantage of a federal investment tax credit that was a 30% tax credit, and it was able to be applied to both the entire upgrade. So the digester itself, which generates the biogas, and the CHP. And so we had great financials here. We basically, if you just looked at the CHP aspect of whether or not to do a CHP, for example, it was very compelling because we were going to get this $4 million federal tax credit because of generating the electricity. Had we not done the CHP, we wouldn't have gotten any of that, even though we had to do the original digester. So really, we were out of pocket about $1.8 million, and we will have already paid that $1.8 million off here in early 2019. We got a lot of positive press, and I'm coming to my last couple slides here. But like Art was saying, there's a nice greenhouse gas offset. You're more efficient, and it's basically creating something positive out of what previously was a waste stream. So we've had a lot of positive environmental press on that. My update, now that we're looking at how everything has transpired over the last several years here at the end of 2018, we have generated over 20 million kilowatt hours of power. We've saved over $1.5 million of utility cost. That's through the end of 2018. We've reduced greenhouse gas emissions by 10,000 tons. Now, if I had it to do all over again, I would have thought about what if our yogurt sales really drop. And of course, at the time, we were thinking the paradigm was that certainly yogurt sales are going to continue to grow. All the trends showed that. But now that they have dropped, we are running that generator less than the 270 days a year we thought we would. And so now we are looking to add a natural gas modification to the generator such that it can run a combination of natural gas and biogas. We could have done that originally, and if I had to do over again, I would have done that, because then we would be running it, north of 300 days a year, which would be ideal for us. We just don't have the straight biogas to be able to do it. So the plant, in fact, I'm going over there this afternoon, and this is one of the things we're discussing, is the progress that the plant has made on modifying this generator so that it can also run natural gas. And I think that's my last slide, maybe. Okay, this last slide, I'm sorry, this is the last slide. And this just shows the different places where we have been written up in a positive way related to the whole project. So I guess I'll stop there and see if there's any questions.
Yeah, we just got one. It says, what would be the estimated cost for that kind of alteration to the generator to accept natural gas?
That's a good question. We were thinking, the last that I was talking with the plant, that the engineers over there that are working on it, it was looking like about $400,000. So, it's in that ballpark. So
I have a question. So if you were going to give advice to someone looking to do a similar system, would you tell them that they should, already right off the bat have make it able to accept natural gas?
Yeah, I think this is an example where what Art had referenced there, where they're able to give some support, some technical support. That's what I would do. I mean, that's what's kind of going through my head as Art was saying that, is going forward on a project, I would definitely want to get Art's group involved in working with any other engineering firm that you may be working on a project, to think through all the possible options that you might have and what would be the pros and cons. And again, for us, of course, from our marketing and our sales teams, their worst case scenario has happened is that we've done all this to be able to generate, or to be able to make Greek yogurt, and now sales of Greek have fallen off. Even Chobani, who led the Greek craze, is now making regular yogurt because they've seen that some of the tastes have switched back now. So I just think that there's probably a lot of things that could happen and a lot of options that it would be great to get an extra set of eyes to consider all of those things. And I think this is one that we probably could have considered, and maybe we should have spent some more time on. But again, it's something that can be modified. It's just a little less straightforward, a little more costly to do it after the fact.
I see. There's another question that just came in. It says, does your marketing team share the sustainability benefits with customers, and how do they feel, or do they approve with that, if so?
Yeah, that's a good question. General Mills is very consumer facing. Of course, we've got many products that are really geared toward to wholesome, healthy lifestyles and things, like our Nature Valley bars, all of our Annie's organic, and so on. So yeah, we're out there trying to make sure all of our positive sustainability news gets featured. We have a global sustainability report that we officially press release once a year that talks about all that. But like this October, we had a ribbon cutting at a wind farm, that 100-megawatt wind farm that General Mills has partnered with the developer on to make basically renewable power and put it on the grid. Things like that, we certainly are trying to get the word out when we make investments like that.
Well, cool. I'm not seeing any more questions coming in right off the bat, but I'm sure that was a lot of information. So I'll definitely be giving your contact information along with Art's for any of our attendees that might have some questions or want to shoot some ideas off. I know that Art and the people over at the CHP TAP program would love to assist anybody that has any type of questions or ideas about how to implement a CHP system into their facility. Actually, hang on, there's another question that just came in. This is just to either you, Art, or Darren. It says, do either of you know other incentives available to public or private sector folks looking at CHP or waste-to-energy projects?
Maybe Art could answer that, but I would say that we're considering some CHP at other sites, not because we have biogas, but just because we think that there's some financial benefits to do so, and there is that investment tax credit, which I think now Art says 10%, but also there's this PACE funding, which Art probably knows more about than me, that is a way to help get some additional financing for things that might not meet our company's hurdle rate. So
that's right, and also some facilities may opt to hire a company that will actually own and operate the system, but you pay them basically for the energy. So there's facilities that, for various reasons, would want to implement a CHP system, but don't either want to be in the business of owning and operating a system, or don't want to have to address the capital costs associated with the system. So there are third-party ownership models out there, and you can then purchase the energy from that third party. And if somebody has specific questions and wants to contact me, I can get them some additional information about different financing options and specific incentives that could apply at their location, if there are any beyond that federal investment tax credit that Darren mentioned.
Well, cool. If anybody has any more questions, feel free to send those. I'm not seeing any come in right now, but if there isn't any more, I'd like to go ahead and thank our speakers again for taking the time to inform us on the important topic of CHP and the benefits of that. I'd also like to thank everyone that registered and was part of the webinar audience. Our next webinar of the series will be March 13th. That's a Wednesday. That will be into 2019. We don't really have a topic right now, but I'm working on that. So be on the lookout for registration links and emails with more information. This webinar was recorded, and it will be available on our website, tennessee.gov. I will be sending out a follow-up email with all the information from this, contact information, and the link to the recording. But if you have any questions, feel free to contact me at caleb.powell@tn.gov. So I'm not seeing any other questions. So once again, thank you guys so much for presenting and giving us some really beneficial information. I hope everyone has a great rest of the week and a very, very Merry Christmas.
You too. Thank you. Thanks. Thank you.
Thank you.